let me introduce myself first. Good evening, everyone. I am Amitava Das, working as University and Scientific Cooperation Officer in French Institute in Northeast part of India. I'm the one who actually facilitates Indo-French scientific cooperation, and my job responsibility includes conducting webinars, workshops, guiding Indian students willing to do PhD, facilitating Indo-French collaborations and partnerships, etc. Today, we are going to have a session on mathematics, artificial intelligence, and information and communication technology. In fact, today's topics are very interesting, as we know that government of France has decided to spend 1.5 billion euros over a period of 5 years, and France is very well known for its contribution in these areas, especially in mathematics. 13 out of 60 winners of the prestigious field medals are French mathematicians. So without wasting any more time, I'm pleased to inform you today that we have with us Dr. Inbar Fijalko. She would be our first panelist for mathematics. She's the head of the Signal Information Telecommunications track of the Master's Program, Intelligent and Communication Systems of CY Cergy Paris University and INSEAD. Professor Fijalko's research involves mathematical tools such as estimation theory, optimization, random matrix theory. She is also the co-author of more than 160 publications in international journals and conferences. She is also representing Ecole doctorale E2M at Cergy, Paris, which is a multidisciplinary doctoral school in mathematics, physics, and computer science. I now introduce Dr. Raphaël Couturier, our second panelist for artificial intelligence. Dr. Couturier is a professor in computer science at the University of Franche-Comté, France. His research interests include artificial intelligence, parallel and distributed computation, applied security, and the Internet of Things. He has co-authored over 200 articles in peer-reviewed journals and conferences. More recently, he has been focusing on deep learning with applications on steganography, image denoising, IoT signal compression, and image restoration on the cloud, and many other applications based on artificial intelligence. He's representing Ecole doctorale ED-SPIM, which is a part of the Doctoral College of University of Bourgogne-Franche-Comté. Our third panelist for today's webinar is Dr. Jean-Marc Duchamp. He has been a research engineer in a company specialized in electron beam called TechMeta France from 1991 to 1996. Then he has worked as a professor of University of Savoie from 1996 to 2005. Currently, he is working as an assistant professor in University of Grenoble-Alpes, and he teaches electronics and telecommunications in this particular university. His current research interests include passive microwave and wave circuits, analysis and characterization like matching impedance networks, filters, power divider, MEMS, slow wave, periodical structures, tunable and miniaturized RF subsystems. His recent topics of interest are RF energy harvesting and wireless transmission systems. He has participated in more than 20 national and international projects, and his collaboration with 10 graduated PhD students now lead to more than 150 referred papers with contributions to book chapters and patents. He is representing Ecole doctorale EEATS, which deals in electronics, electrotechniques, automatic et traitement du signal. I am also happy to introduce Mr. Abhishek Goswami, our alumnus for today's session. Abhishek is enrolled as a doctoral student at University of Paris-Saclay and works at the L2S Signal and Systems Lab of Central Suplex CNRS. He works for the image processing software company, namely DxO Lab, where he has been conducting his research on computer vision and computational photography, specifically HDR imaging. He has extensively collaborated with University of Nantes, France, and University of Cambridge, UK. He is an active IEEE student member. He reviews manuscripts for acclaimed conferences such as ICIP, ICASSP, UCPCU, and journals such as IEEE, TIP, etc. He is due to complete his PhD by January 2022 and will join a postdoc position in the extended field of computer vision. Mr. Sujit Nair, Campus France Ahmedabad manager, he is here among us, although he may not be visible to all of you, but he's our support moderator today. So we welcome you all on behalf of French Institute in India. So before we start this session with our panelists, we would like to inform that students are free to post their questions in chat box, as we have a separate time allocated for the question and answer session. So we would like to start our session with our first panelist, Dr. Inbar Fijalko. Dr. Fijalko, I guess you would take us through a PowerPoint presentation. Over to you, Dr. Fijalko. You will have 10 minutes for your session.
Just for the time to share the presentation. I hope you can see my presentation. Right now, I can see it. Yeah, good. Okay, so thank you for the introduction. And so my name is Inbar Fijalkov, and I'm going to introduce you to the graduate program that we are conducting at Cergy, which is Grand Paris University, so CY Cergy Paris University, which is a joint program with the engineering school NCA and the National Research Center in France, CNRS. And our graduate program is called Intelligent Systems that are Intelligent and Communicating. And the research lab that is associated to it, it's named EEATS. And I'm going to introduce you all of that in more detail right now. So first question is, why should you take a graduate program, our graduate program? I think that the first and more important answer is that you want to acquire more deeper knowledge in applied math to get better, improved work methods, autonomy, but also to discover the world of research, and in the future to get jobs in research and innovation. And that should include both research and innovation as engineering companies, but also in research organisms, or become a faculty in academia. Our new digital world is full with exciting applications. And the applications I'm going to talk about concern wireless communication, energy management, image processing, data sciences, cognitive modeling, and robotics. So I'm not going to talk about all of them, but I'm going to show you that you will need a lot of applied math in order to be able to conduct research in those areas. So our graduate program that starts at the master level, like the second year of the master level, has 3 tracks that concerned with applied math. There is a 4th one about electronics, but I'm not going to talk about it. It's really different. The 3 tracks we offer for students coming from applied math are DSML for data science and machine learning, IER for artificial intelligence and robotics, and SIT for signal information and telecommunications. Both those tracks require really good skills in math. That includes probability, algebra, analysis, optimization. But nowadays, we really need also to have programming skills for all what is concerned in applied math. So the students who can apply for our second year of master come from both applied math and electrical engineering, and all of them need to have good skills in math and some programming skills. On the first year of this graduate program, so the second year of the master, We have a choice of classes in English. So one very interesting thing of our program is that the students can choose the different classes they go to. And so we have some fundamental units, then complementary units that allow to deepen the knowledge. We have one unit about internships and one about language, that is English for the French students and French for the non-French speaker students. And then the students go for a research project that is quite a long research project, and then a research internship. What can you learn about this program? I'm going to go track by track to visit the different aspects and to focus on the applied math aspects of these tracks. So in the data science and machine learning program, so the responsible for them are Dimitris Kotsinos, who is a specialist of data mining, and Sun Vu, which is a specialist of image processing. And they joined both learning to do a lot of basics of machine learnings in terms of really understand the kernels, the optimization that is behind machine learning, not only the algorithms. Issues with databases that are really the scaling effect when you want to consider very big, very large amounts of data, but also how to process each image by itself using different transforms like Fourier wavelet transforms in order to extract features that will allow to characterize this image or multimedia aspects. So as you can see in the lower right image, how the question is how to recognize a face of a person given many different faces. Applications go from surveillance to cultural heritage, with advertising and other aspects about that. Second track concerned artificial intelligence and robotics. This class goes more into bio-inspired neural networks and modeling. So for our research track, the modeling aspect is very important. And it's especially related to cognitive science, where scientists try to model the brain, try to model how our brain, each of our brain, develops, how it learns different aspects, and especially aspects based on vision, that allows us to behave in a natural environment. Once you have models for that, you can put these models on different robots and try to see if these robots behave the way you want our model to behave. And so, as you can see here on the picture, we have different kinds of robots. Some are totally humanoid, some are really far from humanoids, but the idea is really to see how they interact, how they navigate, and how they behave in interaction with humans. And so the aspect is really bio-inspired neural networks, adaptation, and learning. The responsible for this track are Alexandre Pitti and Philippe Gossier. The third track is called Signal Information and Telecommunication. So I'm in charge with this track with Claudio Weidmann. And this track is really the most mathematical of the three, because what we like is really signal processing, information theory. And as you can see on the names of the different classes, all these classes have a lot of theory in them. So what kind of theory? Convex and non-convex optimization, classification, sparsity, information theory that will allow us to understand what is really the important, the essential part of information that is tracked. Game theory to model interaction between players, but also error coding theory that will allow us to understand how information can be conveyed on a different graph. And that will allow us also to define security issues that are related to both privacy and security on networks to ensure that we can have privacy of the transmission of information or the storage of information. The applications of this track, the main application of this track is wireless communication with the different aspect that goes from transmission, like from the antenna, and to networking, with a lot of aspects concerning security that are very important nowadays. Security involves the security of transmission, but also the security of storage. These are very closely related issues. And one thing that we have known recently is that the optimization tools that we can use in order to optimize the resources allocated for transmission are very similar to the optimization problem that we can face when we consider the energy management over a network of energy. And so all the theory that we have been developing for wireless communication, we are now applying them for energy management, and with a nice interplay between the two of them. Oops. Okay. So as we have seen, all these tracks go for PhD in the teams of our research program EEATS. So EEATS is a research lab that is a joint lab for CY, University, NCA, and the CNRS. And we have 4 teams, 3 of them being concerned by the different tracks that I've shown. So signal information and communication for the EC lab, the neuro for the AI and robotics, and data science and machine learning for the 4th lab. So we have many PhD students are coming for these different tracks, and the PhD program is usually composed of students who have like 3 or 4 years of PhD that are fully funded. All our students are fully funded by different kind of funding, some coming from the university, some coming from companies. We supervise about 50 PhD students. So we have a quite small research unit, but we have 50 PhD students at the same time that are really concerned by the different aspects that go from analysis to security, communication, and interaction. And the research objective of our research lab is really to acquire the capacity of autonomy, full learning adaptation of the systems we develop. And we try to implement this intelligent process in complex and most often distributed systems that will make a lot of constraints on our optimization problems. Just an image of some of us, not all of us, like the PhD advisors and the PhD students that are here on this image. And to let you know that our graduate program is in the French top list of its area. So we have been classed like 3rd or 4th of our area for many years now, and also in 2020. How to apply for our graduate program? You need to go for non-European citizens. You need to apply through Pastel. That allows you to enter the program, and e-candidate for the European citizens. This is the application. If you have questions, you can really ask all questions to our master administrator, Mr. Carcagero. Don't hesitate to ask him many questions. In the second year of the master, so for the graduate program, we select 40 students every year. So those students are selected about several hundreds applications. And for the best students that apply, we can offer a few excellency grants that allow them to have a better living in the area. And the application is in April. And then among those 40 students, but also other students of the M2 level, we select about 15 students for the PhD every year, and they're all funded. If you want to learn more about us, please visit our website that is addressed here.
Thank you.
Thank you very much.
Thank you very much, Dr. Fijalko. The presentation was indeed in details, and we are very happy to know that the PhD programs are fully funded. So we now proceed to our next panelist. Our next panelist for today's session is Dr. Raphael Couturier. Sir, you are requested to run your presentation. Sir, a sincere request, 10 minutes for each panelist. Okay, thank you. Dr. Couturier, are you not able to share the screen? You are on mute, sir. I think there was some technical difficulties for Dr. Couturier. In the meantime, okay, he has joined back. Dr. Couturier, you are on mute. No, we can't hear you. Yes. Yes, Dr. Couturier. Yes, we can see your screen.
Can you hear me? Yes?
Yes, now we can hear you.
Okay, so sorry for the presentation. My name
No problem.
is Raphael Couturier, and I will try to make the presentation quite quickly. So first of all, I will present the doctoral school in which we are, and I will present the lab in which I work, and I will present some application of artificial intelligence in our lab, which is called FEMTO ST. So the doctoral school is called SPIM. It's a doctoral school that gathered 7 research units. So FEMTO ST, which is in Besançon, and some other labs that are either in Dijon, another part in east of France in the Burgundy-Franche-Comté part of France, and there is other lab which is called Drive, SIAD, and nanomedicine. So in this doctoral school, there are many different research fields as optics, electronics, mechanics, so a lot of applied physics, but also computer sciences. So I am working in computer sciences, and we have almost 450 students that makes their PhD in 3 years, as all the PhD students in France. So we are in the east part of France, and these are the name of the main cities where all the researchers are working. So I am in the FEMTO ST laboratory, which is decomposed in 7 departments. So most of them are close to applied physics. So the first one here is an control, one on energy, one on photonic, micro and nano, one on applied mechanics, one on optics, time frequency, and I am working in the DISC, which is Department of Computer System, Complex Computer System. So now I can present quickly some application of artificial intelligence in the FEMTO ST lab. So some people are working in computer science or control or robotics. So all of them are working on with classical machine learning and deep learning. But we have also some colleagues that works with machine learning, but not with classical algorithm. So they are working with optics, and they are making a new architecture to without computer to make machine learning. So they are working with optics, they are working with signals in optics, and they are able to simulate neurons with only with physics, without any computer. So it's different, it's really based on physics, and it's really different. So what are the applications of artificial intelligence for which we can work? So some of our colleagues are working on natural language processing, time series prediction, image processing, so either with classification, object detection, or semantic segmentation, or anomaly and fraud detection. So I will now present some example. So one classical example in which we obtain good result is image generating. Suppose you have this kind of images, so it's a noisy image. We can train a neural network in order to denoise this image. So we present different kind of images, and the algorithm will be able to denoise and obtain this result, while the ground truth is this one. So we can do that for several kind of noise, either additive noise or multiplicative noise, and it's really interesting to apply that for many applications because there are a lot of noise in many applications. So another example concerns the medical and hospital. Suppose you have an heart attack. What you will do, you will go to hospital. People in the hospital will make MRI, so it's magnetic resonance images. And you have a lot of images like this, which are very noisy. And what is the goal of the doctor? So the doctor will see, okay, this part is really dead. So it means your heart is in a bad situation. And the goal of the doctor is to segment these images. So what we are doing in this project, and the PhD presented yesterday, so it defended yesterday, we are doing the automatic segmentation of this kind of image. So it's possible also to work on one-dimension signal compression and reconstruction. So here we are working with IoT. We would like to compress a lot the signal. So what we will do, we have, for example, this signal, which is HCG, so electrical, or I don't remember the name. And there is another signal like this. Suppose you would like to compress this signal. So what we have done, we have work on a very lossy compression. So you can see here that many parts of the signal are compressed. So of course we can have a compression ratio between 80 or 100, and then with machine learning we are able to reconstruct the signal after the sending of the element, and we obtain this kind of signal at the end after the reconstruction. So here again we can obtain this. Finally, another work which is very interesting. So of course, firemen are essential in many situations for many for the well-being of the population. And what we can observe is firemen are working more in some period of the day. So what we were interested to do with them is to make the prediction of the number of intervention according to the hours. So here we have several hours and we make several predictions. And we try to incorporate a lot of external data, like, for example, the weather prediction, but also if there is a pandemic, if there is, so we have a lot of external variable, and we integrate all these variables in order to make the best prediction we can. Final present example, we are working with a protocol which is called ADSB. It's a protocol that is used in all the airplanes. So when the airplanes is flying, in fact, they communicate a lot of messages very frequently. These messages are not encrypted. So it means anyone with a very small electronics can simulate an airplane. So what we wanted to do is to attack this kind of signals and try with artificial intelligence to detect that there is an attack. So we worked either with supervised or non-supervised machine learning and deep learning in order to simulate some attacks and train our neural networks to detect the attacks. So I have finished, and sorry for the beginning, that was a little bit.
No, it's fine. It's absolutely fine, Dr. Puturi. Thank you very much. Thank you very much. In fact, in this part of northeast part of India, there are quite a few professors working on artificial intelligence and especially natural language processing. So I will be more than happy to put you in touch with them. So we now proceed to our third panelist, Dr. Jean-Marc Duchamp. Could you please run your presentation? Sir, you are on mute. You have to unmute yourself.
Yeah, sorry.
No problem.
So thanks, Dr. Omar, for this introduction. And I will present here the Grenoble-Alpes University. I could put a S because we have two universities. And especially the doctoral school of EEATS, in which I have some PhD students. And a little bit to slide on my lab. So first, I want to introduce the Grenoble-Alpes University. So it's in the middle of the Alps, at 3 hours from Paris and less than 2 hours from airport like Lyon or Geneva. And we have two major scientist university. One is called UGA, and one is the aggregation of several engineer schools called EMP. And this university is ranked 19 times at the top level in the Shanghai classroom. So Grenoble is quite a small town in France, about 450 inhabitants. And in this area, there are a lot of students, quite 60,000 students, and about 3,000 PhD students. So it represents more than 40% of the total human inhabitants of the Grenoble. All these students are distributed in in 13 doctoral schools with close to 90 specialties managed by 80 laboratories. Around these students, there's also professor, but also a lot of company close to on the campus and close to the company. A lot of publication, of course, and patents are made in this area. So in this 13 doctoral school, we have several type of topics, from the chemistry or the health, humanity, law, language, of course, philosophy, and more precisely, physics, or what we are interested in, electronics, electrical energy, automatic control, and signal processing. So I will try to describe this doctoral school. So this doctoral school is organized in 5 specialties. One is automatic. One, what we call Genie Electric, is the electrical management of the energy. And we have also a nano electronics technology and nano electronics with a large company which is called ST Microelectronics. We have also a specialty around optical and radio frequencies, and of course, signal video processing. So in this doctoral school, we have about 480 students last year, about 100 defense by year, and several what we call HDR. It's for the senior scientists, just to reach next step. The employment after this PhD is close to 100% after 3 years in teaching or in the industry. How you can make a PhD? There's several solutions to find a grant. We have what we call 20% of the PhD student get doctoral contract. So it's for the students that have made their master in the university. You can also find 20% with the industrial partner, which is called CIFRE. We have a great partner with the CEA, and of course, other national research contract found given by HNR or the UN. The origin of all these students is engineer for about 40% and French master for 30%. Other nationality are welcome, of course, but and represent today half of our PhD students. So a slide on my laboratory, which is called G2 Lab. We have about 22,200 person with 100 PhD students, about 30 PhD defense. We have several activities around the energy, the management of the energy, and how to make a static converter of energy, or how to deal with the new problem of with the car, electrical car, or distributing in a smart way all this electrical energy. And to finish, it's several examples of subject of PhD that is available today. One for the study of the secure wireless power system for medical implementation, development of electrode for nanowire network to brain-machine interface, an autonomous control of drone base with wind energy, and how to tower functional value preservation and suitable in the power electrics. and another one around the optical spectrometers. So you can find all this information again on the website of the University Grenoble-Alpes, and especially in the doctoral school EEATS. And Grenoble is still a great city and well prepared to welcome Indian students, I think. I finish and thank you for your attention.
Thank you very much, Dr. Diusho. Thank you. Now, your turn, Abhishek. Could you please share your experience, since you are in France, you're doing your doctorates in France, you'll be finishing your doctoral studies in next 2 months' time, by January 2022. So the Indian students who are willing to do the PhD, they want to know from you, what are your valuable comments? What do you suggest? What is your suggestion for them?
Thank you, Amitav, and thanks to the other distinguished panelists as well for sharing your thoughts. For those who are listening, our audience, I really can't add to the years of experience from the panelists of all the information that you've heard today. You might already get an idea of the different topics about doing your PhD, places you can do your PhD, but I'll make a more general comment. When I started my PhD, there were two facets which I really thought about. One is the kind of environment infrastructure that you have around yourself to make your work count, so that at the end of the PhD, you have a lot of research to show for, and how you can use your PhD as a pedestal or a stepping stone to improve your career forward. Working in France, what I felt very well was it has a very deep collaborative environment. For example, I belong to the doctoral school of Paris-Saclay. We have at the same campus the engineering school, which is Chantal-Choupelec, and the CNRS research lab as well. So there is always a very collaborative networking going on, and it allows, and it's really important for every PhD, and it allows us to not just be cooped up in your own prospective field, but you need to broaden your horizon, which is not just for the 3 years of your PhD, but of course, when you go out for your next job or continue your career in academia, broadening your horizon is very important. And this kind of a collaborative networked environment is very influential. So that was one. And secondly, how you can use it as a stepping stone or plunge yourself in your career. The networking again helps, because then it helps you to go into academia, get your postdoc, which is something that I'm also pursuing. And the other aspect is going into the industry. Very niche domains or even application oriented, the things that you've seen today. In France, there are not just French companies, but also other international major stakeholders who have their industry base, which collaborate with the universities very regularly, and they have those positions where you can make a mark. Down south in France, there's a place close to Nice called Sophia Antipolis, which is considered like the Silicon Valley of Europe. It is Europe's first and largest science park of sorts. So that's it. Like, you have a very strong industry as well as a research network in France, which honestly has helped me in my PhD in the last few years. And I'm hopeful whoever is coming can make full use of it and move forward in their careers. Thanks.
Thank you very much, Abhishek. So students should keep in mind that they should not restrict themselves to one particular area, but they have to broaden their research. Now, I have got a few questions for the panelists as well as for Abhishek. So the first question is, I have a maths MSc, Master of Science, and currently pursuing AI and ML. I am looking for a research role, PhD in applied maths and AI. Any suggestions for faculty I can connect with? So this question is open to all my panelists.
Please contact us.
Okay. So
yeah, I mean, it's
can
definitely.
we share your contact IDs with the audience? Okay, fine. The next question is, I'm a bio major, currently in biomedical data science. project in ML, no master level math exposure. Can I apply for ML here? Is there any scope for doctoral programs on pure maths? I'm searching for a PhD position in cryptography. Is there a scope in this area for applied maths area?
There were different aspects, like the bio aspects goes well together with like signal processing and image processing, so that can be one aspect. So even if you don't have like an applied math, but if you add enough probabilities, filtering and signal processing, you can definitely do a PhD on image processing for health application, like imaging and like different transforms from the imaging, things like that. The cryptography aspect is totally different. That requires a lot of math that is combinatory, probability, and that requires really to have more math in it. I mean, but the two of them don't go very well together, so you need to choose.
Okay, so I think we have to close the session, and I request my colleague Sujit to mention the mail IDs of each panelist on the chat box so the students can contact them directly. I sincerely thank each of you. I know how busy you are, and despite your busy schedule, you have agreed to join us in today's webinar. I also thank my colleague Sujit, the support moderator, for his logistic help. I'm really grateful to each of you for your contribution. The session and especially the PowerPoint presentations were extremely helpful, useful for the aspiring students who would like to do PhD in France. I am sure the students have really benefited from this kind of session, and we will organize this kind of session in the near future. So feel free to contact us anytime, and we will also keep in touch with you because a good number of professors are working on these domains. So thank you again for joining us today. Thank you and goodbye.
Thank you.
Thank you so much.
Thank you.
Bye. Hope to see you in France.
Bye-bye.